Hi, I'm Richard C. I'm a math tutor here at Wyzant, answering questions submitted by a student. It's a nice little calculus question, and it has to do with distance traveled. We're given the velocity, so what I think we're going to do is work on this a little bit and then take it from there. So the velocity, and let's just start by factoring out a 6. Because we want a little graph of this, little sketch of this to help us figure out what to do. So that's a 3 there. And we can factor that. So it's t minus 2, t minus 1. So we can get a nice little sketch of this thing. I'm just going to ignore the t for a moment, the 6 for a moment. So we're going to have two intercepts at 1 and at 2. And we know it's a parabola opening up, and we know when t is 0, this is going to be 12. This intercept here. So it's going to, and we know the vertex is going to be halfway here. We can sketch in a little vertex at 1.5. 1.5, this is t here, of course. This is v here. Okay, so it's gonna come in looking like this. We don't know how far down it's gonna go. But what we're interested in knowing here is when velocity is positive, when velocity is negative. You can see it's going to be positive between 0 and 1, and velocity is going to be negative between 1 and 2. So this means that we're moving right. We're moving right. You think of the particle going along a line, for example. Be moving right. It's moving in the positive direction, and here it's moving in the negative direction. So we know that the antiderivative or the location, we call it s of t, is just going to be the integral of vt. And if we want the total distance traveled, which is what's implied by the wording here, we're going to take the distance traveled when t is negative, when, v is negative, and the distance traveled, the integral here from 1 to 2 is going to be negative, so we have to, distance. It's going to be the positive portion minus the negative portion, because this is going to give us, moving to the left, the location, which is s here. The location is going to give us negatives. So if we want the total distance traveled, it's going to have to be the distance when v is positive minus distance when v is negative. So this is going to be 6 times the integral v of t dt from 0 to 1 minus the integral from 1 to 2 of v of t dt. Okay, so let's just do this. So it's 6 times, so we'll just take the, we've counted for the 6, we just need to account for what's in here. So this is going to be t cubed over 3 minus 3 halves t squared plus 2t, going from 0 to 1 minus, put a big 6 in front here, the same thing, the same antiderivative, t cubed, so put a bracket here, t cubed over 3 minus 3 halves t squared plus 2t, going from 1 to 2. Okay, so this first one, it's going to be 1/3 minus 3 halves plus 2 minus 0. And then this one, I'll just bring the 6 along now just to, so this is going to be 8/3 minus 6 plus 4. That's evaluated at 2 minus what's evaluated at 1, which would be 1/3 minus 3 halves plus 2. Okay, now we just have to deal with some fractions here. So it's going to be 6. This is going to be come out to 5/6 because this is 2/6 minus 9/6 plus 12/6. It's going to give you 5/6 minus 0 minus 6 times. You just work your fractions. You're going to get 4/6 minus 5/6. And this is going to give you, you can see that the 5/6 will add together. So let me just keep the 6 out of here. Is you're going to get 5/6 minus a negative 5/6, so it's going to be 10/6 minus 4/6. So it's going to be 6 times 1, which would be 6 feet. So that's the total distance traveled. The tricky part of this is negative versus positive direction. And that's given by the sign SIGN of the speed, the velocity, not speed, the velocity. Speed, by the way, is the absolute value of velocity. But velocity gives us not just the magnitude of the travel, which is speed, but it also gives us the direction of the travel. And so in this region here, it's traveling to the right, but then from 1 to 2, it's traveling to the left because velocity is negative. And that's it. So that's the way to do this one. I hope this was helpful. I'll see you again next time. Bye-bye.